Today we're looking at two more shortcuts for proving triangles are congruent to one another. The first one is the angle-side angle congruence theorem, which says that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So here we have an illustration of that. Notice these two angles are congruent to the two angles in the other triangle, and the side between them is congruent to the side between the other two angles. That's why it's called angle-side angle, because the side is between the two angles in each case. So triangle STR is congruent to triangle NMP by angle-side angle. By the way, I do need to fix something on this one. That's not actually a theorem. This is actually a postulate. We don't make that big a deal out of it, but this is not a theorem. This is a postulate. Now, this last one is a theorem. It's the angle-angle-side congruence theorem. Here we've got two angles and a not included side of one triangle that are congruent to two angles and the not included side of another triangle. Then the triangles are congruent. So we've got two pairs of congruent angles still, but the side isn't the one in between them. It's one of the other sides, and it doesn't really matter which. Then these two triangles will be congruent by angle-angle-side. And again, the reason it's called angle-angle-side is because the side is not in between the two angles. So those are our two new ones. So I was asked this, and it's a good question. There are two combinations of three parts that cannot be used to prove triangles congruent. They are angle, angle, angle. You can't use that to prove the triangle's congruent because even if the angles are the same, might one triangle be a lot bigger than the other one? Yeah. These two triangles are going to be similar to one another. Same shape, but not necessarily the same size. The other one is side-side angle. We don't use that because if I keep the angle and these two sides, I can make two completely different triangles out of those. So side-side angle cannot be used to prove triangles congruent. And it's pretty easy to remember not to use it. So in your head, spell it backwards. If you don't want to be one, don't use side-side angle. Okay, it's ridiculous, but if it helps you remember it, that's fine. All right. So I don't know why I wrote flowchart on this one, but we'll do it as a flowchart proof. Oh, I didn't point out this to you guys in our last class. Because I'm easily amused and also easily bored, almost all of the ones that I write spell something in some way or another. Okay? So you can watch for that just if you find that amusing. If you don't, that's fine. So like, frequently they spell somebody in my family's name, or like this one that spells frost, which is wishful thinking at this time of the year. It's a little too early to get a frost here. All right, so we're given that angle R is congruent to angle S. Again, if you really don't like flowchart proofs and would rather do this as a two-column, that's absolutely fine. If you want to write it out as a paragraph proof, that is also fine. So angle R is congruent to angle S. And then we're also given O is the midpoint of segment RS. With that first piece of given, we already know things are congruent, so we're not going to do anything else with it for right now. But O is the midpoint of RS. We should be able to use that to get some things that are congruent. So you don't need to draw this, but we're just looking at this part. If O is the midpoint of segment RS, what conclusion can we make then?
RO and SO are congruent.
All right. RO is congruent to SO. But we have to be able to give a reason for that. Yep, that's exactly right. That's the definition of a midpoint. So these two are congruent to one another. And then, as almost always happens in these, you run out of stuff that you can get from the given. When that happens, there has to be something that's true, something that's congruent because of the way it is in the diagram. Yes, ma'am.
Angle FOR and SOT are congruent because they're vertical angles.
Exactly right. Those vertical angles never going away. So since this doesn't come from either of these two things, I'll start like it's a new piece of information. Angle FOR is congruent to angle SOT because vertical angles are congruent. Or you can write the vertical angles theorem if you would prefer. Well, now we have three pairs of things that are congruent, and generally speaking, that's enough. The question is, which of our four shortcuts are we using here?
Angle side.
Yes. Why is it angle side angle?
Because we have an angle and then we have a side and then we have an angle.
Yes, because in each triangle, the congruent side is between the two congruent angles.
You're using asa.
So now we have triangle FRO is congruent to triangle STO by angle side angle. All right, let's do another one. So we'll have our statements. I'm going to do this as a 2-column. If you prefer a flowchart proof, you're welcome to do it. I tend to put all of the given in the first step. I think you probably noticed that your book doesn't always do that, which is fine.
Proof fat cat.
Yes,
And it spells fact.
and it also spells fact. In this case, we weren't given anything is congruent to anything else. That automatically ensures that this is going to be a little longer than the other proof. But we start off with, what is this the symbol for? Perpendicular. If lines are perpendicular, what do you know is going to happen?
Right angles.
We're going to get right angles. Specifically, we'll get right angles where those perpendicular lines intersect. So AF and FT intersect at F, so that's going to be a right angle. And AC and CT intersect at C, so that's going to be a right angle. So we'll write angle F and angle C are right angles. And how do we know that?
Because perpendicular lines create right angles.
Yes, and you can write it that way, or you can just write definition of perpendicular lines. Either way is fine. I kind of like the way you said it. Perpendicular lines create right angles. But you could just write definition of perpendicular lines if you'd prefer. Either one is fine. But that's still not anything as congruent.
Angle F equals angle C.
Well, equals?
I mean, is congruent to angle C because they're both, right angles, so they're both 90 degrees.
So,
Definition of right angle.
well, the definition of a right angle would say the measure of angle F is 90 and the measure of angle C is 90. To shortcut having to go through all that, what we'll do on this is just say that all right angles are congruent. I mean, you're right. They're both going to be equal to 90, and so they have the same measure, and so they're congruent. But that's like 3 steps. So we can do this in one instead. All right, so I've got a pair of congruent angles. Yay. I need at least 2 other things. Yes.
Since we know AT or oh wait. Never mind.
Okay.
Wait, no. Because AC bisects like the CAF.
Uh-huh.
Doesn't that mean that those two angles,
Those 2.
both sides of A are
Which
congruent?
name them?
FAT and CAT?
Yes. Exactly right.
Angle fat is congruent to angle cat.
Indeed. And that's the definition of an angle bisector. Sort of like we've used the definition of midpoint, right? A midpoint divides one segment into 2 congruent segments. An angle bisector divides one angle into 2 congruent angles. All right. At this point, I've got 2 pairs of congruent angles. Angle, angle, angle isn't a thing. It doesn't prove triangles congruent. So that means somewhere in here I've got to have a side. I'm getting the same volunteers all the time.
Yeah, man.
Lloyd.
AT is congruent to CA.
I'm sorry, which one?
Angle A or segment AT is congruent to segment CA.
AC?
AT.
Oh, AT. Sorry, I kept thinking you were saying C. Yeah. This side is a side of both triangles. So segment AT is congruent to, you can turn it around like you were doing if you want to, or you can just say AT is congruent to segment AT. What's the reason for that? Yeah, the reflexive property. Once I have 3 pairs of congruent corresponding parts, that should be enough. So which of the shortcuts can I use to prove the triangle's congruent, Ian?
Angle, angle, side.
Yeah, and why is it angle, angle, side instead of angle, side, angle?
Because it's 2 angles and then a side.
And where is the side? It's not in between the 2 angles.
It's not in between the 2.
There we go. So triangle FAT is congruent. That's a really horrible congruent sign. Triangle CAT by angle, angle, side. Okay, I won't tell you.
Oh. Okay.
Any questions? Okay.